Okay, we're carrying on. We got all the way through the first 10 elements, filling out these configurations. Yes, we want to say how many electrons, what element it is. These are orbital diagrams configurations to the right. So we are going to start right here. And actually we'll start right here with sodium. And sodium is like neon. And then we add one electron, the 3s. And so we get 1s2, 2s2, 2p6, 3s1. Now, obviously, if I'm going too fast, just pause it, get the stuff copied, then move on to the next slide. Magnesium, we know, has 12 electrons. And now that 3s is filled. And so we have this 3s2 at the end. And those would be that would be its valence electrons. 2 electrons, 3s orbital. Now we have no choice for the next 6 elements. We are going to be filling those the p subshell. And so there's our first electron in the 3p, so at the end it's 3p1. Here are the valence electrons, 2 and 1 is 3. Not surprisingly, aluminum's group 3. We hit silicon, close cousin of carbon. And the key thing here is, didn't pair up. It goes into an open orbital, so these things stay unpaired. Electrons don't like each other, so this minimizes repulsions between electrons. So we have our 1s2, 2s2, 2p6, 3s2, 3p2, and we see it has 4 valence electrons. The pattern continues. There's phosphorus, and it has 3 unpaired electrons in the 3p subshell. And there's its configuration, 1s2, 2s2, 2p6, 3s2, 3p3. The fun never stops. Now with sulfur, we're forced to pair off one of the electrons in the 3p subshell. And so we end up with 1s2, 2s2, 2p6, 3s2, 3p4, 1, 2, 3, 4. So each slash represents electron. We are almost there. Chlorine, lots of slashes to do. And again, here we are. There's its valence electrons, 2 and 5 is 7. So chlorine is either considered to be group 7 or 17, depending on how one looks at it. But generally I would say 7 because it reminds you that it has 7 outer electrons. We're arriving at a Boston Bruin again. And here's argon. And look at all those perfect crosses. And there is its configuration. All these subshells are full, a very stable arrangement of electrons, and of course it has 8 valence electrons. So make sure you know the difference between configuration, orbital diagram. Whenever you do an orbital diagram, make sure you label the orbitals. Try to spread out the different orbitals, leave a little more gap so we can see which is what. And you should be in business, but read questions carefully, because sometimes we want configurations, sometimes orbital diagrams.